function words or stop words and content words in a lexicon. Okay. Some standard words like these are called stop words, all the prepositions, conjunctions and things like that, and some common words. And the other things are called content words, which give you some meaning. There is some tax errors to you. All of expressions, including both the spoken as well as written, textual, about 60% is all this stop words. Prepositions, conjunctions, etc. And this set of words. 40% is only the content words. That's the okay. So, in order to find out how do you attach some rating to a filling word, okay, in a scale between 1 to, I think in this case, 1 to 5, like good, bad, polar. Good is 5, bad is 1. Ugly, beautiful. So something like that. So at the extreme ends, and the grades between these. How do we do it in the mind? That's the idea. Of course, in computer science, people and all the applications of the whole world of analytics is concerned with sentiment analysis, review analysis, all kinds of things, in which they try to attach some numeric quantity to this sentiment words or feeling words or emotion words used synonymously. What we did was to get to know how to rate these. There is no particular direct corpus available which is experimentally validated. So one of the things we do is to look at what people say. So essentially, we looked at book reviews again. We take a lot of these book reviews from Amazon book reviews, and then consider these many sentences in these many reviews. And one thing is, there ought to be some correlation with the types of words you put in and the star rating you give. Okay. So, fantastic, you probably will give 5 star. You won't write fantastic and then say 1 star unless you say not fantastic. But if it is, I'll come to that, this graded assessment. Not fantastic is not placing lousy. It's something like that. All these grey demarcations are there. So these are expressed in these sentences in this form. So we essentially use this star rating as a final score and do some lots of weighted jugglery over. So this is the demonstration of that. So first is negation, and these kinds of negations, and usually this is a sheer negation, and contra. This is a conjunctural form, but sometimes can be used to express a slightly polar viewpoint, but maybe a qualified thing. Great, but not as expected. These kinds of reviews you put, you don't know what you are saying. You are saying neutral, okay. You say great and then say not the way it should have been. Now, what do you say out of this? Do you say it is bad? Because great was 5. Okay, so it somewhere reduces. So these are all qualifiers which reduces. These are conjunct, sometimes conjunct, sometimes prepositional forms, which will. Okay, so this sort of, please first look at all these reviews, take all this data, and now okay, one thing is okay. So one thing to notice is the use of this quantifier not to express an opposite viewpoint actually occurs more in those code reviews. Ratings of reviews which are 2-star seem to have more of this kind of thing. So it's like saying, okay, you really don't want to say bad things. That's a human tendency. You slur it. Okay. So whereas the positive things, the occurrence of that is much lower. Positive, extreme positive, 5-star rated stuff. and of course some normalized number averages and so on. So these are some basic scores we build. Okay, no. Okay. Using these basic scores, you can build some quantification of the range. Okay. And it is known that there's a graded scale between happy and unhappy. So this is, you might expect it to be a positive 5 rating or something like that. This may be, you expect it to be 1 rating, but in between it is sort of, it's a gray zone. Okay, so anyway, you use some different types of weighted measures for what we now call, usually this is based on all adjectival terms. Okay. There are about 8,000 adjectives or something which are in the lexical corpus, American National Corpus or some standardized lexicon we use. We process it with word data and things like that. And cull out the adjectives and check the adjectives which appear in the ratings and look at in the reviews and look at the ratings and try to attach some weight to the word which appears in the review with a certain rating, score between 1 and 5. This is for all the words which appear in those reviews which you have. Okay. There are words, adjectives which have not appeared in the thing, you need to get some more. And this is the nature of this work. This work, the slightly important part of it is that a few thousand, about 8,000, I think about 1,000 words have ratings in the 30,000 reviews which have appeared. So you can attach some score by some weighted means. Now, there are the remaining 50,000 words, 5,000 adjectives, on which we like to get some attachment of an emotional or a rating score, inferring from that 3,000 words, which are human subjective, human participant data. So here is where the little bit of what is called as a crowdsourcing kind of experimentation is being used. After all, human beings are rated, so they are already expressed. So they have expressed words with some ratings. So you try to infer a quantitative score out of it. The propagation to the remaining is by graph theoretic means like that. Okay. So there is something called okay. Now what we do is we look at the American National Corpus, standard corpus. Now look at all the words which have appeared for some threshold number of times. If they have appeared 45 adjectives, if they have appeared over 45 times, there are 2,000, 40,000 adjectives in these 5,000 reviews. So essentially, they contained some number, total number, and about 45 was this. So less than 45, there was a few ignored them. So then you look at JJ is part speech tag adjective, and popular, not popular, and things like that. They have occurred with at least 10 times this much, and so on. So now what you do is, where is this network? So it's meaning now the shades of meaning between adjectives. There is a whole lot of shades of meaning, right? Now these shades of meaning are exemplified in various thesauri and in a particular machine readable standard compendium called WordNet, the UPenn database. It's a very phenomenally wonderful database which has been developed over a period of time. Which is also built in as part of natural language processing toolkits called NLTK, and which has a nice language called Python associated with that. So all these things you can do out of basic statistical tricks. Okay, that's it. But the interesting thing about it is this: the original part of speech tags. These are called adjective, satellite adjective, which is somewhat similar, and then the nouns and then the adverbs and verbs. It's a very standard corpus. Now we have lots of adjectives. There are about 9,000 adjectives. For 3,000, we have, let's call it, reasonably robust scores. Some weighted scores. but from human contributed database. Now, the synonyms which are in the lexicon, or synonyms are many other relationships which are written up there. In particular, they are applied to adjective, a few of them. We can use to propagate on a network the scores which humans have given to particular adjectives to other similar adjectives. That's the idea. So here is where graph theory and network theory comes into picture. So we have this adjective network. On this adjective networks, it's like what's called as a graph in which there are some scores associated with some vertices. Many vertices do not have scores. So how do you propagate these scores? Now, this is reminiscent of situations in other parts of theories. This is called belief propagation network in a certain domain. This is called some learning network in some coding, decoding arena. Essentially, you have a network, you have scores for some things, which let's say are robustly connected. Now, you want to pass on these scores to others, which are related by an adjacency relationship from this graph. So it's like you have some beliefs about certain things, and there are some other things you don't know, so you pass these beliefs. This is done by certain iterative network traversal mechanism, and that's what we deploy and all that thing. But essentially, you look at the relationships and just summarize the. See, the thing is, there are many kinds of relationships which are what richly brings out. These are few which will be zero for adjective because they are all meant for nouns. You know, superclass, hypernym, subclass, hypernym, meronym, holonym, all kinds of things. So these are all nouns. These are not very noun adjectives. But things like something about similar is something which is humans say something is similar to something. And it was captured by human annotations in this word meaning. And antonyms and some derivational forms and things like that pertains to that. So these apply to qualifying words like adjectives, and you can use these relationships in some weighted form to build a graph, and on that graph to return a lot of things. And this idea, and I think I should probably stop at this point just to get the final message and we can have some discussions. So.